your data before scaling your data team. Some disclaimer, I'm not going to talk about data stack. No, maybe, so no modern data stack BS. And also there are more memes and GIF in that presentation than slides. So please don't be shocked. All right, a little bit about me. So I'm Belgian, but I've been living in Berlin for the past 2 years. I've been working as a data engineer, recently as a staff data engineer. Does anyone know what a staff data engineer is?
You do whatever the fuck you want with data.
Yeah, that's basically that. No, but so basically I'm on the technical track. People come to me when they have a technical problem, not when they want a salary raise, right? So I've been working for the past 4 years in hypergrowth environments. So Klarna, you may know, Back Market, which is a French unicorn company, and recently Trade Republic. And I'm actually create content online, so under Medio on YouTube, LinkedIn, Medium. I also launched datacreators.club, which is a website where you can find data creators on different topics, machine learning, data science, and no matter their channel, so Medium, YouTube, Twitter, you choose your channel. So go overhead and also have a podcast with them. I play too much League of Legends in my free time, right? And I'm also an husband and father, and this is my beautiful family with a GDPR compliant picture. So yeah, if by now you're asking yourself how I'm doing everything, I just have a cloning machines. That's pretty easy. Now the reality is that I'm still struggling with a lot of things. But one thing which is really easy to do is to subscribe to my YouTube channel. So this is the name, okay? And yeah. So what's an hypergrowth company? So this is really a basic graph. There is different definition. But basically, there is different stage, and you see the growth over there is happening in a short time. And usually, it's a company that has achieved a lot, has some success, and it's ready to take to the next level. So they have a product. They have a product market fit. They may have some revenue, maybe not. And there is a difference between growth and scale. The growth usually really involves a growth of resource, right? So let's say you have a 300 people company. If you are in hypergrowth, you're gonna double that in a year. So it's like 25 people coming each month, right? So that's huge. And scale is basically when revenue, you get more revenue with less resource, okay? So it's like a revenue stability. So they usually also had a big funding round to reach, of course, that level. And the tricky part, again, as you see, is that the time is really, really short. So I'm going to talk to you about the challenge in such environment, but also most of those tips and tricks also apply at different level of your company. So fact number one, unless you're not working on planet Earth, hiring data profile is hard, okay? So especially if you are in a hypergrowth company, you have this current data guy, which needs to do the technical interview. You maybe have one hiring manager, one TA, so talent acquisition, a bunch of candidates in the pipe, and new hires that are struggling with the onboarding process. Fact number two is that 1 year in a growth company is a dog year. Does anyone know how much human years is a dog year?
6 years.
Yeah, so it's like 7, 15, depends on the breed, but like 15, let's say 15. So this is huge. And to come back to my example, right, 300 people company to 600 after a year, that's literally another company, right? You need different process, you need the department, the culture is changing. So keep that in mind. And another point is that data is at the center of everything. And usually you have different teams for microservices, have products, and you see that the data team is really at the horizontal level, which basically right in the middle of the huge spaghetti, right? That makes the problem even harder for data teams. All right, so let me tell you the story about Bob. So this is Bob. And the story about Bob is also AKA the df.show mistake. Does anyone knows what does I can reassure you directly, this is the only line of code that you're going to see during this presentation. Phew. So does anyone know what does a line of code do?
It will probably show you whatever's in that df object.
Yeah.
Probably the data frame.
Yeah, exactly. So it's an Apache Spark method to print basically the content of a data frame. So you just print a data frame. All right. How many people are comfortable with Apache Spark here? Okay, so like 1/3. So let me introduce you to Apache Spark. At least you get that for the evening. Pretty simple. So Apache Spark is a data processing framework to basically that enables you to distribute your code against a cluster of machines. Wow. So let's take an example. If you have a book, and let's say you need to count the number of words in that book, okay? As a one-person, one machine, if I need to read all those books to count the words, that's going to take me time. I didn't realize that I say one person, one machine. Anyway, so if I split this book, let's say in two, and I distribute my code to a cluster to some workers, say, what's your name?
Raj.
Raj? Okay, so I give half of it to Raj, okay? And so I have one worker and Juan, and the other half to Juan. So now I have two workers, and each of them is going to read half of the book and count the number of words, okay? And me, as a job manager or as a driver, that's the Spark term, I'm basically going to sum just the intermediate results, okay? So this is faster because then now I have two people splitting the work, and I have the sum. Does that make any sense? Okay, so roughly speaking, that's Apache Spark. And the problem here is that show basically just print the data frame. And it's like asking Rohan to count out loud every single page, which is completely useless and probably annoying. So it's inefficient in terms of resource, and that's what the df.show is basically doing on a cluster at scale. So not hurtful when you're working locally and debugging, but hurtful at scale. So let's look at Bob's data pipeline stat. So every hour, he runs an incremental data pipeline job. Time is 10 minutes. Price per job is 22 cents. So it's 158 euro per month. And for 10 data pipeline, like 1,580 euro per month. And by the way, this is realistic number, right? It's not like for a small data set or a really huge data set, but that's like what could possibly happen. So now if you remove that line of code, right, the df.show, and preventing Juan to speak out loud, the time of the job is now 6 minutes. So, okay, 40% of improvement. And the price per job now, of course, decrease per month too. And you guess it, for 10 pipeline too. And that's a saving of 630 euro per month. So, okay, your pipeline is cheaper. But how could we avoid this situation where Bob put like one single line of code that's costing money? Do you have any idea? Okay, we're pretty silent. Who would fire Bob?
His manager.
Yeah. So, yeah, that's true. So the thing is that it's not Bob's fault, okay? And that's not the worst. Let me tell you the backstory here. So basically, Bob is actually a new hire. And that new hire kind of mostly copy-pasting the code of this OG data guy I show you, right? Which is just firefighting. And why is he firefighting? It's because he has business which is screaming at his desk for asking things that was for yesterday. And why this business is screaming is because you have your VC, which is asking where is your money. So you remember that time lapse, it's 1 year, okay? And they want some return. That's not the worst. There is more, Bob. By the way, this is a rigorous speech. I'm not Bob in the story, or at least that's what I want you to believe. So yeah, more Bob. Yeah, there is always one scary VC. And if you do the maths based on my example, well, it starts to be almost 2,000 euro per month of money lost for one line of code, okay? So the point here is that every small problem can be a big problem at scale in a hyper-growth environment. Yeah, that's for sure. Thank you. That's obvious, Captain Obvious. But so to remind you, this is where we are, right? And so that little problem, that little DF show, which like, that's not too much. If it's scalable, you have 25, you remember, new Bob coming each month. So do the math. So how can we avoid this? A couple of tips. The first one is that know your data and your TCO, so total cost of ownership. So adopt FinOps from day one. The cloud is super expensive. Like the thing with like when we had on-premise cluster, when you launch a big job that takes a lot of resources, you're just blocking the others, right? And the other, I cannot do my job. Not everybody can do your job, but it's just your credit card which is burning. So there is a lot of things today to put like budget alerts and so on. The thing I usually do when I arrive on a new data stack, I'm asking how big the data are. But like, what are the biggest data asset that we have? How fast do we compute the data hourly, daily? Do we have streaming pipeline? What's the growth? What's the growth in terms of, didn't realize, you don't say anything. The growth of data usage, both in storage and compute, the growth of the use case, and how important. So this one is actually interesting because once you get a bit more mature in terms of like where my money is going, what's the biggest job, what's the biggest data assets, you can ask yourself, okay, I have those 3 jobs which are really expensive every month. Does the data that's being used for business is relevant, right? So can I just like do less refresh or archive the data to a cheaper storage? Tip number 1, hire smarter than you. Again, it sounds obvious, but in a hypergrowth environment, you don't have time to learn. You need an expert to tell you how to do so. Remember, you know, the OG data guy, the dog ears, and the VC. So invest into a hiring process. You need tech talent acquisition, engineering branding. So engineering branding is all around your Medium blogs, open source initiative. That's attract talent. Doing meetups with free pizza. You get the point? And also, please, no FANG style interview. I've seen some scale up hypergrowth company doing like, you know, those conservative technical interview with algorithm and DSA style. If you cannot pay like a FANG company, just adapt your process. Invest into the onboarding process. If you remember on my first image, it's really important that you have your 25 bobs that's being efficient. Yeah, we have time question after. No worries. Just after, no worries. Keep your question. Don't forget it. We have time after. So automate as much as you can access management, documentation, and reproducible development environment. This one is really underestimated. I've seen some company, like a good like rule of thumb is like if you have a new hire, like a developer, if you can merge a change in production within the first weeks, that's a good win. I've seen some company do that on the first day. That's like just you know, below the sun, but that's really nice because it pushes your team to think about, okay, does my new hire will have all these access already on the first day? Do we put some script to install things on his laptop already? So on and so on. Finally, don't hesitate to ask for external help. So freelance or trainings are a good way to set up best practice and foundation. Even if it costs you more money, on the long run it will pay because there is so much Bob coming in and so much df.show happening. You want to prevent that early. So who should you hire? I'll let you guess. So the thing is, you need to keep a good ratio of data engineers in your data team. So don't let the data engineer die under the Velociraptor, and don't accumulate too much data scientists or data analysts. They will just queue for the data engineer. So today's ratio is still wrong. In general, if you look at all the company, and one reason is that hiring data engineers specifically is really hard, and people tend to disregard the necessity of a good data engineering foundation for basically time to market or faster delivery. So you need to find a good ratio. This is a really opinionated number, but let's say like a good starting point is 1 data engineer per data scientist / data analyst. But of course, this number will evolve as your company grows. Third, enable data self-service. Oh no, here comes the data mesh thingy. So don't be the middleman. And the thing with, how many people are familiar with data mesh? I feel like more than Apache Spark. That's interesting. So the point is, like people tend to think, okay, now we need to decentralize data team and so on. But the truth is you just need to find the right level of decentralization for you. And so start by building a data platform. And also what works really well, I've seen in the past, is inner source. So basically open sourcing internally a project. Especially for a data platform team, they're going to build like a framework to enable other people to do stuff, right? But they're not going to use that tool. So a data platform, good question. Basically, it's like a centralized data team that enable other data citizens in the company. So for example, you could have data engineer in a product team that will do the actual pipeline, right? And the data platform will provide the tool, let's say provision, the cluster and so on, maintaining the cloud data warehouse for you to run your pipeline. So yeah, inner source works really well because if you have like kind of those overlap of responsibilities, you can say, hey, we have this framework for you. If you want to contribute, here is the documentation and so on. We still own the roadmap of the product, but you're free to contribute. Limit what your user can do internally, the data folks. Too much freedom, it will be the Wild West. So what do? You restrict things, but if you restrict, it will be the Wild West too, because shadow IT is really a thing. So if people cannot do their job, they will find worst workaround to do it, right? So you need to find really the right balance and to be basically close to your user. Treat data platform as a product, and please, please hire a product owner. And finally, you can also push back ownership on different levels. If we come back to our example with Bob, pushing back visibility on cost and ownership on the budget, say, hey, Bob, you have like 1,500 euro on data pipeline. You know, it's your budget. You want to look at it? And if he's aware, maybe you know, there is a money incentive to say, maybe I should look into my pipeline. Buy versus build. So this is something basically you need to evaluate all the time. So it's basically time to market versus technical debt. So you can buy a solution that does something off the shelf, right? But you need to evaluate locking risk and your agility to move out, because it can cost billions to move out from this. It can cost billions from the tools, but it can also help you to bootstrap a lot of things. And of course, building things in-house and maintaining it with a certain team is also super expensive. So the point is, I can really see people changing data stack quite often. Like, okay, I'm buying this tool, you know, that does that, and you know, in 2 years I have a bigger team and we're gonna do something on our own, more adaptable. And if you go to FANG, like Facebook, they only have custom tools. So tip, basically, the more your company grows, the more you're gonna actually build a custom in-house solution. Promote knowledge sharing. So knowledge sharing is caring. It's not scaring, it's caring. And one thing that can help is guilds and tribes. So per function, let's say data science, data engineer, again, to prevent, like to say, hey, we should not put a df.show in production. That's not the best practice. And so with that, foundation matters. Software engineering best practices often overlooked in the data teams, as well as data modeling. Finally, blog, newsletter. So here I'm talking about internal blog and newsletter. Don't forget, 25 more Bob coming each month. So those 25 Bob has no clue of your team or what you're doing. So having an habit for your data team to have a weekly internal newsletter, hey, here's what we've done, here's what we are planning to do, some KPIs on the number of jobs, of the data size, will bring visibility to the others and basically help you also to be closer to your user. Hackathon also help. Don't expect like that much output during hackathon, but it really brings the people together, and knowledge sharing is really nice into that mode. Okay, so scaling data before scaling your data team, wrapping up. So know your data, hire smarter than you, keep a good ratio of data engineer, enable data service, self-service, buy versus build, and promote knowledge sharing. And yeah, so don't forget, every small problem can be a big problem at scale, especially if it's a company where you have dog years. So Another small problem that you can easily solve is subscribing to my YouTube channel. Please just do it. Take your phone. I won't mind, right? And if you don't like my style of presentation or whatsoever, just share it to your enemy, your ex-wife, ex-boyfriend. I don't care. Anyway, another announcement is that I'll be at the Coalesce conference in New Orleans, which is a conference, and I'm not going there as a speaker. I'm going there as a reporter, so I'll be interviewing data expert backstage. So if you want crispy gossips about data, this is also the channel you want to follow. Thanks you. Yeah, why basically the ratio is important and which profile should you consider. So the point is, like as I showing in the picture, data engineer is at the core of everything. So if you don't have good data pipeline, then basically those people are just going to queue up. They just cannot work. And this happened in the past. I can tell you big corporates, because I worked at so before those company in big corporate insurance, and there was a hype like when data science was really hype, like all those corporates hired like PhD data scientists. Don't get me wrong, I have nothing to do wrong with the PhD people, but the point is they were thinking, okay, let's do AI, let's do machine learning, that's fine, and they didn't realize that the maturity of data foundation didn't enable that. And what happened is that a lot of those data scientists either quit or became data engineer because like most of their time were spending on cleaning data rather than spending time on machine learning or analytics.
I have a question. What's the difference between the data platform team and the standard DevOps platform team?
That's a really good question. So what's the difference between a data platform team and a standard DevOps platform team? I think they're going to merge pretty soonish. I hope so. So if you remember my first picture, you see that there was silo and the data was really apart. But basically, today, the data platform team provides application and development tools for data citizen, where the DevOps is really focused on basically software engineering backend and front-end people. I hope that we'll go together because this silo is also bringing a lot of basically misunderstanding in the flow because as you saw, like data is at the center of everything. So I think they should be embedded into the same platform.
I've already seen into industry where DevOps is also providing infrastructure and tools to the data team.
Yeah, I think it's happening. Yes?
One question regarding ownership. You now said that the data platform team should sort of provide tools for other application teams. My question would be, what I've seen is that a lot of application teams like integrate into a data mesh, then sort of own a little bit of a black box, and if a pipeline breaks for one or the other reason, who's responsible for sort of owning it? Is it educating the application teams as much as, okay, you can debug your own stuff, which can be challenging? Imagine a backend PhD team that suddenly needs their own data pipeline, no offense towards PhD people, but that can be an issue. Or is it more like that the data team at that point has to come in and sort of debug that?
Yeah, so the question is like, based on the product that the data platform team is giving to the user, would be responsible if there is a data pipeline fail, because they are not the user of the products, but they do build a framework, right? Did I get that right? So it's a really tricky question because, again, you should separate like the logic of the data pipeline itself, right, from the core framework. And if a pipeline fails, it's not obvious, like, is it the business logic which is failing, or is it part on the framework? So I have no really answer to that. I think how I would look is if you look at no-code or low-code tool, right, which is provided that you can buy from outside your company, right? Who is responsible if something fails? And it's again the same situation, right? Like the no-code or low-code provider can say, hey, but you configured that wrong. So I think what's really important here is to work hands in hand. Like I think inner source is really nice to kind of like share responsibilities on things, right? So I would say education is one thing that can help, but again, it's depending on the skill set. So it's a really tricky problem. Yes.
Let's say I'm a CEO at some kind of startup company and seeing my, let's say, data warehouse costs increasing, and I'm now here listening to you and I want to talk to my CTO and ask him, how can we like start find out where the inefficiencies of my data pipelines are? What would you recommend?
Yeah, so I think like the basic is building dashboards on data, so both storage and compute. So storage is really easy. You just list like what are the biggest table on your cloud data warehouse or your biggest S3 assets, right? And you're gonna have a price on it. Regarding the jobs, you have like cloud data warehouse like Snowflake. They also provide visibility on queries, and you can have a cost on the credits, so you can see exactly which are the most expensive queries. So build those dashboards and then push back a weekly notification to the user. Hey, this is the top wall of shame that I like to call it, and just send it like this. People is gonna react. So because again, you push back the ownership and say, oh, damn, I think we can do something. But if you don't bring this visibility to the user, they don't have that much incentive to actually change something.
What's a good time to do that? Like if you pre-optimize it, prematurely optimize this.
Yeah.
You might be losing more in money in developer time than for the data warehouse.
Yeah.
Like I feel like a lot of this talk is very geared towards a scale up.
Yeah.
Imagine you're like early stage startup.
I would argue, like, if I give the basic, let's say you open like an AWS account now.
Yeah. I agree with those things. Like you should have, dashboards, and you should have like.
No, but like the question, what would you do if you have an AWS account? Like, what's the basic that you would do?
I've never managed an AWS account, so I couldn't tell you.
No, but like just to answer, you would go to the UI, like create a budget alert. Let's say, okay, 20 euro per month, done. Okay, so that's enough. I don't need to know what I'm spending or whatsoever. So I think there is different level. That's my point. And I think in cloud data warehouse, it's the same. They offer things from the basic, right? And then as you grow, you go more into the details, right? So maybe if you're a small company, doing just an overall credit usage on your cloud data warehouse, it's enough. And then when you grow, you start to need, okay, let's dive into which query is getting inspected.
I think that was basically the gist of my question. Like, how do you find a good balance of like when to do that?
Yeah. I think today, like especially like what's happening at the macro level in terms of recession and so on, I think it's really super interesting to have this FinOps approach. One thing is that data engineer added value is often completely forgot, right? It's always the data scientist, the machine learning engineer that get all the pride. But something that you can act upon like really easily is your cost, your own cost on your platform. So let's say you have your jobs, your data pipeline, you have no clue of where this data is going, but you can say to the manager, hey, we reduced the cost by 15%. That's like, that's like really clear KPI that you can link to some dollars. So I think as a data engineer, it's also a good way to show your value, basically.
Would you say it's better to like leave the responsibility to data science?
Let's keep it after. There is other people, and I think there is pizza.
I think that we will have to slowly wrap
Yeah.
up.
So yeah, I'm in between you and the pizza. Is that okay? So let's take one question, and you can come after ask me. Yeah.
So in our company, data engineers is also like way less in number than analytics engineers, and I'm wondering how should data engineers that build a platform collaborate with analysts? Should they be in the same team, in a different team?
Yeah.
Like how should they work together?
Yeah. So
data engineers and analysts and analytical engineers.
Yeah. So basically, you're asking if so the analytics engineer and analyst should sit in the same team or outside. It's really, again, it depends. You need to find the level of decentralization. I would say that analytics engineer, there is a strong, that's a strong term because there is engineer in it, right? So I would say you can normally trust them more, right? With like software engineering best practice. And so I would put them like close to data platform at the beginning. And then as more as you grow, put them, some of them maybe in the product team. But it's always finding the right balance between, depending on the size. Thank you. Sorry for taking too much time. You're free to come ask me many questions you want just after.